In this video, I will show you how to solve systems of conic sections, and we're going to use the elimination method this time around. Now, understand that when you're talking about a system, you're talking about two or more equations, and what you're really doing is you're looking for the intersection point between those shapes. Now, this would be a system of circles that I've drawn here, but in problem number 1, notice that the top equation is a parabola, y equals x squared. The lower equation is a hyperbola. So, I mean, if we're talking about a parabola and a hyperbola, let's just do a possibility, right? So, here's a parabola, and a hyperbola is this type of thing. All right, like here's a hyperbola. Okay, is the shape that has the branches. So we could conceivably have 4 solutions if it did something like this. But there are all kinds of possibilities. There might only be 2 solutions, or there could be no solutions. All right, imagine that the parabola did something more like this. Swoosh. All right, then there would be no intersection points at all. So let's solve the system and see what happens, but there are lots of possibilities here. For the elimination method, you want to have all of your like terms lined up. So let's go ahead and move this x squared over to the left side of the equation. All right, let's put it in general form. So I'm going to have to subtract this x squared from both sides. So the top equation will become negative x squared plus y is equal to 0. I just simply subtracted x squared from both sides. The bottom equation did not change, so I'm just going to recopy it like it is. X squared minus y squared is equal to 4. For the elimination method, we want opposites that cancel, and we just happen to already have that. Okay, if I combine these terms to make a new valid equation, these are going to cancel each other out. These are not like terms, actually, so I'm just going to have I'm going to put these next to each other. So I'm going to have negative y squared plus y. All right, they're not like terms because this one's squared and this one's not. In fact, I probably shouldn't have even lined them up. But it doesn't matter. I see it now, so it's fine. If I add these together, that's going to be 4. But the key is these x squared terms cancel each other out. Now all I have is the variable y. So this is something I can work with. I'm going to subtract 4 from both sides now. So that'll give me negative y squared plus y minus 4 is equal to 0. For the things that I like to do, like factoring, I need the leading coefficient to be positive. So I'm just going to multiply everything by negative 1. Or you could think of it as dividing everything by negative 1. Whatever makes you happy, but the bottom line is all of these signs are going to change. Okay, this is what I like better. Now I would like to try to factor this. Okay, I'm not sure this is factorable though, because 4, it could either be 2 times 2, and there's no way I'm going to get a negative 1 out of that, or it could be 4 times 1. That's not going to work either. So I'm going to go ahead and use the quadratic formula to try to solve this. So according to the quadratic formula, y should equal opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, a is 1, b is this negative 1, and this positive 4, that's c. So the part underneath the radical is called the discriminant, and you should always calculate that first before you do anything else. So that would be negative 1 squared minus 4 times 1 times 4. So that's going to be positive 1 and then minus 16. So that's going to be negative 15. Well, this is a negative number. A negative number underneath a radical is imaginary. So we are not going to have any real solutions here. So we're just going to write none. Okay, there must be no intersection points between these two. It must be this type of situation. In fact, I think I'm going to go ahead and graph this on Desmos.com. And here you can see it is just as we suspected. The green one, of course, is the y squared. The orange graph is the hyperbola. And the parabola has no points in common with the hyperbola. So that's why we got no solution. Let's take a look at number 4. They are already in general form with the like terms all lined up. So all I need to do is create opposites that cancel. So it's up to me whether I want to target the x's for elimination or the y's. I'm going to go ahead and set my sights on the y's. So if I multiply it by 9, then that would make this 9y squared, which would be the opposite of this. So that's why I'm going to take the top equation and multiply it by 9 to create opposites that cancel. So the top equation will become 9x squared plus 9y squared is equal to, alright, I'm grabbing my calculator real quick, 36 times 9, that's 324. Okay, now the bottom equation, I did not change anything, so I'm just going to keep that the way it is. So 4x squared minus 9y squared is equal to 36. So now I have opposites that cancel. So I can make a new valid equation by combining these like terms. So these are going to cancel out. So here I will have 13x squared equals, and this is going to be what is this, 360? Next, I should divide by 13. Now I am seeing really ugly numbers coming. So normally I try to get exact answers as much as possible, but I have a feeling we need to go ahead and switch over to decimals at this point, because this is just so ugly, and then later we have to substitute this back into the other equation. So decimals, if there are no objections, I'm going to start using decimals from this point on. I think I will use 4 decimal places until the very end of the problem, and then maybe I'll round to 2 decimal places at that point. So that's what I'm going to do. This will be plus or minus, keep that in mind, whatever this is. Approximately 5.2623. So this is 2 different values for x. I'm going to try them both and see what I get. Alright, so I'm going to go ahead and start by substituting in the positive version of this back into one of the original equations. So I'll use the first original equation. So we have x squared plus y squared is equal to 36. If I take this value of x and I plug it back in, so if I put 5.2623 squared plus y squared is equal to 36. So that gives me 27.6918 plus y squared equals 36. So now I need to subtract 27.6918 from both sides. So that's going to give me y squared is equal to 8.3082. But then I need to take the square root of both sides. That was odd. And this will be plus or minus. So this is going to give me y is equal to plus or minus 2.8824. Okay, so I'm going to begin to write down my final answers now. Okay, so I just used a positive x value, so that was 5, and now I'm going to round to 2 decimal places. So that was 5.26, comma, and I have these two y values. So, and I'll round this to 2.88. Okay, and then we have this second y value, so I also have positive 5.26, comma, negative 2.88. Okay, so those are two solutions. Now, if I had substituted negative 5.2623 instead of positive, I would have gotten the same values for y, because imagine this had been negative, you squared it, it would have become the exact same thing, and the rest of the problem would be the same. Alright, when you square something, it becomes positive anyway. So, I would have gotten the same two y values. So I can just write down negative 5.26 would have given me the same two y values, positive 2.88 and negative 5.26, comma, negative 2.88. So these are the 4 intersection points. Let's go ahead and put this into Desmos.com and see how we did. So what we have here is a circle and a hyperbola. And as you can see, the circle and the hyperbola have these intersection points. Okay, and check it out. We have, well, let me slide this over a little bit more. We have negative 5.26, comma, 2.88, positive 5.26, comma, 288, and the exact same values that we have right here. So we're geniuses. Alright, let's try number 5. We can use the method of our choice this time. So last time we used the elimination method. So maybe I don't want to use that on this one. See, we have x squared and we have y squared, and then down here we just have x and y. So it would be really difficult to make opposites that cancel. So instead, let's do substitution. So if I were to get y by itself for this equation, so look, I've got x plus y is equal to 1. Okay, and then I've got x squared plus y squared is equal to 16. Subtracting x from both sides, I have y is equal to negative x plus 1. So what I can do is I can take this and substitute it for y in the other equation. So then I will have x squared plus, and then I have negative x plus 1 squared is equal to 16. So that's going to be x squared plus, and I need to do negative x plus 1 times negative x plus 1. So let's see how that works out. So this is going to be, okay, so that'll be positive x squared, and negative 2x, and then plus 1 is equal to 16. Combining like terms, I've got 2x squared minus 2x plus 1 is equal to 16. Subtracting 16 from both sides, I've got 2x squared minus 2x minus 15 is equal to 0. I wonder if this is factorable. The last few times I've tried to factor, it was not factorable. This is not factorable either, so I need to use the quadratic formula, which goes like this. X should equal the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, the first thing we should do is use the part underneath the radical. That's called the discriminant. Let's do that first and see if this even has any solutions at all. So remember that this is a, this is b, and this is c. So I'm just doing b squared minus 4ac right now. So that's going to be negative 2 squared minus 4 times 2 times negative 15. Alright, so the discriminant is 124. It's not negative, so this will be doable. So let's go ahead and figure out what the rest of the quadratic formula says. So opposite of b, so that'll be positive 2 plus or minus the square root of 124 all over 2a. So a is 2, so 2a would be 4. Okay, so let's just find the decimal forms of this. We'll do it once with a plus and again with a minus. So these are the two values we're getting. So I'm going to go ahead and start building my solution set. So I've got positive 3.2839 comma something, and so there'll be a y value that goes with that, and we have negative 2.2839 comma something, and we need the y value to go with that. So let's start with the positive 3.2839 and substitute that back in to this little equation right here and see what we get. Okay, so that would be y equals negative 3.2839 plus 1. Well, we don't need a calculator for that. That would be negative 2.2839. So that's the y value that goes with this x value. Okay, now let's find the y value that goes with this x value. I'll just change colors to differentiate. So again, we have y is equal to negative x plus 1. You can think of this negative x as the opposite of x, if you like. So the opposite of this is going to be positive 2.2839 and then plus 1. So that's going to be 3.2839. So that's the y value that goes with this x value. So that's pretty funny how they're like the same but reversed. Okay, so these are the two solutions, and I guess at this point I could have rounded them down to 2 decimal places. Let's look at Desmos and see what this looked like. Before we look at Desmos, let's look and think to ourselves, what kind of shapes these are. So we have x squared plus y squared equals 16. That is a circle. And then we have x plus y equals 1. Well, that's a line. So we have a circle and a line. So you can imagine we have a line passing through a circle, and we are finding these two intersection points. Let's look at Desmos. So as you can see, we have the circle with a line passing through it, and these are the two intersection points. Negative 2.284 comma 3.284 and 3.284 comma negative 2.284. And I do believe that that's exactly what we had for our solutions. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.